What is special relativity? Well, here we can see a little introduction. Yeah, special relativity is like entering the twilight zone. Okay, that's what it is. So, if you looked at the twilight zone, you're looking at special relativity. Einstein didn't invent anything new. Or you could say that the Twilight Zone did not invent anything new. It was already there. Anyways, what is special relativity? Well, special relativity is specifically the world of flatland. In special relativity, in flatland, right, you cannot fall downwards because there's no gravity. Straight line, straight flame. Okay, so you cannot fall. It's built, special relativity, on a world called flatland. It's all flat. Okay, there's no gravity, and it's funny that I have here Mr. Stephen Hawking, and he puts in his book that he was kind of smirking at a woman who said, "The world is really a flat plate supported on the back of a giant tortoise, standing on turtles all the way down." Apparently, this was a woman who said that to Bertrand Russell. And so good old Stephen Hawking, he kind of laughed at her, like saying, "This is what people believe out there, flatland." But it turns out they believe in flatland as well, because here you have good old Stephen Hawking, and he says the following. He says, "We are only one time dimension and three space dimensions in which space-time is fairly flat." Okay? That's what we see, right? And what's the issue? He continues, he says, "Why did one time dimension and three space dimensions flatten out?" So yeah, he's talking about flatland. That's the world of special relativity. In fact, he's not the only one who says that. Here you have an article from Astronomy Magazine. Says, "What shape is the universe? As far as cosmologists can tell, space is almost perfectly flat." So flat earthers, eat your hearts out, okay? But what does this mean? And he says, the article says, "The most cosmological evidence points to the universe density as being just right and that it expands in every direction without curving positively or negatively. In other words, the universe is flat." So we're not talking about the flat earth anymore. Now we're talking about the flat universe. And of course, if the universe is completely flat, I guess the earth is flat as well. And here's Discover magazine says, "Does the universe go on forever? Is outer space finite or infinite? Explore this age-old question." He says, and then they answer, "A few generations of telescopes, Kobe, WMAP, and Planck, sought to understand the shape of the universe. Was it curved like a ball or flat like a piece of paper?" Now that's straightforward. Is it flat like a piece of paper or round like a ball, right? All three telescopes say the universe is flat. Okay, so I guess Stephen Hawking was laughing at himself and at his colleagues because they all believe in that the universe has the shape of a piece of paper, which is flat. What else can we say? They say our universe is like that flat one there. I think there's no mistake. Special relativity specifically and general relativity in general say that the universe is flat. And in the case of special relativity, they're going to be playing around with this flat universe, and they're going to, work with time, with mass, and with length. Okay? Actually, distance, as we covered in the past, distance traveled. And they're going to play some fancy things that, approach the twilight zone, actually exceed the twilight zone. The twilight zone got all the ideas from special relativity. Okay, so what happened? Well, last week we talked about the fact that these people are trying to, violate the rules of special relativity. today. And why? Special relativity says that you can only travel at, in the best of cases, right, the speed of light. That's the limit, the speed limit of the universe. Nothing can travel faster than light. Nothing that has a body, right? And but they had to invent something to overrule that, to bypass that law of the universe. So they invented wormholes, they invented tachyons, they invented warp drives, they even invented the chronon, particle of time. So they have all these inventions, all these notions, all these ideas that they've come up with to try to beat the speed of light. They don't like the speed of light. It's a limitation, and you can understand why, because when you try to get to the nearest star, right, like Proxima Centauri, it's 4.3 light years away. That means traveling at the speed of light, assuming we could achieve that, right, or very close to it, it would take 4.3 years just to get one way, 9 years approximately, round trip. That's a long time to wait for a trip, for an expedition. Who would fund it? Who would pay for such a thing? So no, they had to beat the speed of light. They had to show that there was some magical way to go faster than light from here to the nearest star, let alone to other stars. They had to give hope, not only to the other mathematicians, but to the world, because people would start asking, well, hold it, takes 9 years to do a round trip to the nearest star. When are we ever going to do that? Hey, don't panic. We can go faster than light. That's the message, right, that gets across. And what is the problem with all that? Well, a lot of that is a problem with definitions. Okay, here's a definition of motion. That's the first one that they needed to tackle, and they never did, in all of mathematical physics. Not just special relativity, general relativity, quantum mechanics, string theory. In all of mathematical physics, there's not a single rational definition. In fact, there's not a single definition. In most cases, or I'd say all of them, they simply tell you, we don't know what time is. We don't know what a point is. We don't know what a line is. We don't know what mass is. They have like 7 different definitions. They don't know what energy is. So they have all these non-definitions. And yet they use all these words every day. And you say, how can they, express their ideas? How can they explain a theory if they don't have any definitions of the main words, the critical words they're going to use to make their case? I hope you're following me here, what I'm saying here. Yeah, if you don't have a definition of your words, how can you express your ideas? How can you express your theories? Does it mean that they don't understand it? Absolutely. If they don't understand it, can you understand it? Absolutely. Okay. So here you have, this is my take on this. Many living entities have the superpower known as memory, right? Almost all mammals, you would say, or lots of them at least, right, have memory. I don't know about insects. Maybe birds have memory, yeah. Humans, for instance, can record in their brains the previous location of objects. Okay, so you know that there's been a previous location, like, you take a lion, lion already understands that there's a previous location of the deer, and then what follows, they sense motion. But motion is out there. And what I say there, because of this, humans perceive motion and premiere the movie in their brains, because they have memory. See, if you did not have memory, you'd only see location here. Then you lose your memory. You wake up again, or you recover your memory, or whatever. Suddenly you see, or your sight really, and you see the new location. You turn off, you see the new location, and you don't have memory that this thing moved. And it's only thanks to memory that we, perceive this motion. However, objects do indeed change locations out there, outside of you, outside of your brain, right? Falling from a tree or shutting a door on your fingers, that proves to you that there is motion. because you feel it in your own, body. Things move by definition if they occupy sequential locations, whether there is an observer or not. Some people say, tree falling in the forest, does it make sound? Well, sound is motion, right? And so the tree falling is also motion. Whether there's someone there to see it or hear it, we don't care. We have a definition for sound and for the tree falling. We don't need to have an observer. And so motion, two or more locations of an object. Okay. So we do have a definition for motion. It's two or more locations. If an object occupies two or more locations, we say it moved. That's physics. We're done. That's how simple the word motion is. And what was interesting is that Newton was not able to define the word motion, among others, right? Or time or space. He just says, because we all know what it is, or have an intuitive notion of what it is, right? Okay, if that's motion, what is time? Well, the difference with time is that whereas motion is out there, time is not out there. Okay, there's no ticking clock, nothing flowing out there. Relative or absolute, doesn't matter. There's no time out there. Time is in here, okay, in the brain. Whereas motion is out there, time is in here. Okay, there is no process called time occurring out there. No ticking clock, no pendulum, no nothing out there. The earth goes around the sun, we say it's a year. Year is a notion we created. The earth just goes around the sun. That's it. There's no God of time saying, oh, that's 1 year. No, we defined it that way. Okay. Time occurs in the mind of the observer. The two objects are moving out there. The two objects move out there, but time is happening in here. Okay. There's no time out there with the two objects moving. It's the comparison that you make. Time involves the motions of two objects, memory, right? You need that memory, and a comparison made by an observer. You need to compare the two motions. Here's an example. The earth going around the sun, okay? That's one motion. Another one is the second hand of your clock, right? And it goes around. When it goes one tick mark from one tick mark to the other, we call that 1 second. The earth went around the sun 30 kilometers. And if you add those 30 kilometers up, you have a full year. That's what time is. It's a comparison of two motions. Okay, I wave my hand and I look at my clock and I say, it took me what? So many seconds. 3 seconds, 2 seconds, whatever. Okay, so time is a comparison of two motions. That's what it is. And no one has ever defined time. In fact, it would destroy all of special relativity if they did define time. So they had better never try to define time, because it will destroy special relativity. Not to mention also general relativity, which bases a lot of its, ideas on special relativity. That's where it originated. General relativity originated with special relativity. Okay, so when did time start? Well, according to the mathematicians, this is when God set the world in motion. He turned on time at some point in time, right? They say it's like 14 billion years ago. Okay, and that's how our universe was created. Of course, religious folks say, "Hey, where did the singularity appear that started the whole process?" That's the issue. And of course, the relativists can't answer that question, especially on the one hand, they're atheists in general, and they don't believe that there was a God that set things in motion or created the singularity. That's one problem. And so people say, well, where did the singularity come from? How do you create something from nothing? And they don't have a definition for nothing. As always, they don't have definitions. And they never define nothing. And they think space is a thing. And so we have this thing called space and this thing called matter, all these things, and they came out of nowhere. And so some of the mathematicians take the view that, well, we don't answer questions of what happened on the first frame of the Universal movie. We just start at the second frame when the singularity is already there, and we have no way of knowing what happened before the singularity or how it came to be. And others have this oscillating universe where the universe, collapses and then starts again and collapses into a singularity and then begins again from a singularity. So it's like a cyclical one. So they have all these ideas of how the universe, came into being, how it started, how it progressed, and how particles, were created, right? And here you have the universal movie that they set in motion, that the mathematicians set in motion. In other words, they never start at the singularity. Their universe always starts is always in the middle of the film. It's always moving. At no point does it remain static that you can identify the first object and say, this is where the universe started. And here it is. Watch it. Here's the movie. Okay, you see the singularity just getting bigger, I guess, becoming this thing we call the Big Bang, okay, what we know as a Big Bang, okay, and it's always in motion. You never see it stopping in a way that you can analyze, especially the first frame in the film, okay, and that's the issue. So they don't have a starting point for the for the movie, for this great movie that they sell, which is the Big Bang Theory, okay. How do we do it in science? We do it a little different. We start here with the universal movie, and we say that in a single frame of the universal movie, every atom is at a given distance from every other atom in the universe. So if you had God's eyes and you could see every single atom in the universe, you take a snapshot of that with your super camera. Here it is. You're taking a snapshot of it, of the universe. We'll call that Father Universe. And you see every atom in the universe only at a given location and at a given distance from all others. And that is essentially the definition of location, the set of all distances from all objects to a single atom or to whatever you designate as a target. Could be you, right? So time is an invention of living entities. We invented time because we have memory. Father Universe only recognizes location, a static concept. All concepts up there that you see in the yellow square there are all static concepts. Father Universe is what? Every atom in existence at a given distance from all others. That's Father Universe. Okay? All atoms in existence can only occupy a single frame in the universal movie. So there's only one frame. Next frame, you do not have a cloning of every atom. In other words, when the atom, we say, moves, every atom in the universe moves to a new location, and it no longer exists in the previous location. It's not like the atoms are cloning themselves, okay? That's an important point because that destroys all of special relativity. Special relativity has this memory where they say, oh, but the atom was over there, now it's over here, but it's still over there, and I can go back in time and stand on that atom. No such monster in the universal movie. So what serves as a backdrop to all these atoms we collectively refer to as matter is known as space or vacuum. In other words, nothing. What is something? Something is that which has shape. What is nothing? Also known as space or vacuum, it's that which doesn't have shape. Okay, we have that which has shape inside of, or you could say encapsulated, or whatever serves as a backdrop is this thing we call nothing or space. Father Universe has no memory, so Father Universe doesn't keep track of time because time involves memory. You can't do time without memory, right? And so here we have good old Father Universe. So Father Universe does not recognize a universal movie. Okay, that's us. We see the movie. We see the moon moving. We see the sun, the earth going around the sun. We see motion. Right? Father Universe doesn't recognize a movie. Father Universe only recognizes location, a single frame in a universal movie. Motion is an alien concept to him. Father Universe is only aware of location. In the next frame, all of the atoms that comprise Father Universe are all at a different location. So Father Universe is not aware of this because Father Universe went to sleep for a gazillion years and just woke up from the last frame. Okay? So he awakens, all he knows is at that location is the distance of every atom in the universe from all others. That's all he recognizes. He's not a spectator, he's merely an actor. And he doesn't analyze himself like we do him. Okay? So Father Universe He goes to sleep in every frame, okay? Goes to sleep, he doesn't know anything about anything. All he knows is got all the atoms there, right? All at a given location. Goes to sleep for a gazillion years, wakes up in the next frame, right? Again, he just sees every atom at a given location. Okay, so he doesn't know anything about motion because he doesn't remember what happened in the previous frame. He doesn't know what's going to happen in the next frame. All he knows is at this point in time, every atom has location. Then he goes to sleep, wakes up again, next frame. That's the way it works, okay? Father Universe does not recognize motion or time. Okay, Father Universe also suffers from amnesia. Father Universe lost his memory. Father Universe doesn't remember anything. He does not have a filing cabinet or save files in his computer. So if you want to travel back in time, you better not consult him. He doesn't have any memory. He doesn't know what that is, right? So it's funny when you have people like Brian Greene here, it's shown him in the past, and he's going to jump into a wormhole and see himself in the morning a few hours earlier and shake hands with himself. Yeah, that might be in the religion of mathematical physics, in special relativity, right? But not in science. In science, this is ridiculous. It's irrational. It should not be even shown as science. And this was from a documentary on science, so you can see that what they're feeding the public. They're feeding garbage to the public. This is nonsense. Wormholes and going back in time, absolute nonsense. And why did they have to create the wormhole? Why did they invent the tachyon? Why did they invent the warp drive? Because they needed to go faster than light. Otherwise, we have no hope here on Earth. We have no place to go. We all die here on Earth. They said, no, we got to give hope to the mathematicians so they can continue doing equations, developing equations. We have to give hope to people who ask, mathematician, are we stuck here on Earth? No, we're not. See, we're going to go to Mars, and we're going to go to the nearest star, and finally we'll conquer the whole galaxy and maybe the whole universe. That's the story they give you. And the question is, can we travel faster than light? Well, if you leave it up to special relativity, it says no. But yeah, laws are there to be broken, right? That's why they made these laws, these mathematical laws. Okay, so here's the Universal movie. And one of the problems is that you cannot time travel. Okay, and so no matter how fast you travel, even if you were to travel faster than the speed of light, you would not be able to time travel, meaning you can't go to the past or to the future because they don't exist. That's how simple it is. And here's just a way of illustrating that. You know, if you're in frame 631, you're just at a given location with respect to every object in the universe, no problem. Frame 632, do you make a clone of yourself in the next location, or did you move? You know, which happened? I mean, should there be two people there in that frame? Is that what Father Universe would find every atom in the universe and two of you? Suddenly, you know, there's two of you, and maybe of every atom in the universe. Next frame, you get three, and so on. You're moving down the line, and there's always a new you. So is this what happens, that we create clones of you in every location, every frame of the film, in Father Universe's film, the one that he doesn't remember having? You know, he only recognizes a single frame. And so, yeah, we have a problem. And then so when people say, well, this guy, you know, the farthest guy on the right there, he wants to travel to frame 633 to shake hands with himself. Several hours earlier, you know, number 3 there in frame 633, can he do that? Can he travel through a wormhole or through top of a tachyon or warp drive or whatever? Can he go back and shake hands with that guy? No, because that frame 633 does not exist any longer. That's the problem. Okay, so, you have to look at this from a rational point of view, and that is that we cannot time travel with or without a wormhole, assuming a wormhole existed, right? We're such monsters out there in space that you could just get into the tunnel with your spaceship or nude or whatever and go to the past. What are you going to encounter? Where's the past? What atoms are you going to encounter in the past if the atoms are no longer where your memory says they were? Okay, that's the issue. Up here, you can memorize anything you want. You can imagine going back and talking to Atahualpa or Moctezuma. You can do that in your mind. But do these atoms called Moctezuma, are they still there? Right? Are these atoms assembled there and you can go back and shake hands with him? I don't think so. And this is the issue. The issue is that these people are selling garbage. They're selling garbage when you talk about time travel to the past or to the future. Again, the future hasn't happened, and the atoms are not there where your mind is. Your mind is in the future, but the atoms are not there. Your atoms are right here. That's the real world. And so are your atoms of your body going to travel to what? To the future of Earth, that the atoms are not there yet? Here you have the way irrationality works, which is the top particle, right, or ball or whatever, object. And you can see that it just occupies different locations. But the mathematicians have this notion that they make clones of all these balls and that you can go back in time to whichever one of those balls. Okay, each one at a different location, but the location is still there because of time, which involves memory. So you can hop to the past and land on one of those balls. And that's what's irrational. Objects can now occupy only one location at a time. They've been developing for the last 100 years equations on all this inexistent stuff. Everything related to special relativity is garbage. It's nonsense. None of it survives rationality. But then they've created, the warp drive, the tachyon, the wormhole. They created dark matter and black holes, which black hole zero dimensional. How can a black hole be there if it's zero dimensional? It's not even an object. And you say, Bill, it's not zero dimensional. Yes, it is. Okay, it is because Subramanian Chandrasekhar, Indian guy, he won the Nobel Prize in 1983 for proving mathematically, right, that radius of a black hole is exactly zero. Radius is zero. That sounds like no volume, no size, no shape. Yeah, that's what it is. Singularity is absolutely zero. And obviously that's one take they had to get around that, so they created the other version. And that is that singularity is really a point of infinity, and you never reach infinity. Meaning that all the matter which supposedly was crushed out of existence, the sun that collapsed to become a black hole, a singularity, all that matter supposedly was crushed out of existence. There was no matter, meaning no mass, meaning a black hole has no size or no mass. And they said, no. All the matter is still there between the event horizon and the singularity. It's still falling. It's falling forever. It'll never reach the singularity. And that's the other version of a black hole. So they had to solve the problem, and some of them believe in one singularity. The other people believe in the others, So you take your pick, okay? Okay, so what they've been doing is developing equations for all this nonsense, wormholes and space-time and virtual particles, right, that fill the vacuum, right? They have black holes, the tesseract, which is the four-dimensional whatever, which is really a three-dimensional version of two nested cubes, etc. They have all this nonsense. Okay, and so now they're, I guess, developing equations for leprechauns and unicorns. So that's the state of special relativity in a nutshell regarding time.